Permeability of soil in geotechnical engineering, the hidden force beneath every structure. What if soil could breathe? Beneath every building, bridge, and road lies a silent decision-maker, soil permeability. It's not flashy, but this one property can make or break entire structures. In geotechnical engineering, permeability isn't just about how water moves, it's about how we design, defend, and sometimes even rescue what we've built. Imagine water rising under a foundation or bursting through a dam. This is where permeability steps in as the hidden force engineers must master. What is permeability really? Permeability is the ability of soil to transmit water. Think of soil like a sponge. Some types allow water to flow freely. Others barely let it drop through. This water movement depends on factors like pore size, soil grain shape, and compaction. Engineers measure permeability using a coefficient, usually in meters per second, to determine how fast water flows through soil layers. It's not just a number, it's the key to predicting water pressure, seepage, erosion, and soil stability. Why permeability matters in geotechnical design. Imagine designing a foundation without knowing whether water will drain or pool. That's like building on a ticking time bomb. In retaining walls, tunnels, and slopes, poor permeability can lead to water buildup, raising poor water pressure and lowering soil strength. That's how landslides happen. On the flip side, high permeability soils drain too quickly, risking settlement and shifting. Permeability is the difference between solid ground and hidden danger. Different soils, different behaviors. Let's compare. A gravel and coarse sand. High permeability. Water flows fast, great for drainage, but poor for retaining pressure. Silt. Low permeability. Slow water movement. Watch out for swelling and shrinkage. Clay. Very low permeability. Water barely moves. This traps moisture and increases pressure behind structures. Each soil behaves differently, and geotechnical engineers must test and adapt before making any design decisions. How do engineers test soil permeability? There's no guessing in geotech. Engineers use two main methods. Laboratory tests. Constant head test. Used for sands and gravels. Engineers maintain a water level and measure flow rate. Falling head test. Used for silts and clays. Water drops over time, and we calculate the permeability from that rate. Field tests. Pumping tests, borehole permeability tests, and packer tests give real-world data for in-situ soil conditions, especially in large infrastructure like dams and tunnels. Testing isn't just routine, it's mission-critical. A small miscalculation in permeability can lead to disasters, flooding, or foundation failure. Permeability and real-world structures. In dam design, engineers use impermeable clay cores to prevent water seepage, surrounded by permeable filter layers to control pressure. In highways, pavement sublayers are designed with drainage materials that depend on the soil's permeability. In tunnels, water infiltration can cause collapse unless carefully managed through drainage and linings informed by permeability data. Even landfills use layered systems, low permeability barriers below, high permeability drainage layers above, all calculated to prevent contamination of groundwater. How permeability affects safety and cost. It's simple. Bad permeability data equals bad design decisions. Structures over clay may face uplift or expansion if not accounted for. Buildings over sand may settle unevenly if water drains too fast. By understanding permeability, engineers prevent expensive corrections, avoid structural failures, and ensure long-term performance. It also influences material choices. Should you use gravel fill? Need a geotextile fabric? Is dewatering necessary before excavation? Permeability decides. Conclusion: the invisible hero of ground engineering. Soil permeability is the invisible hero in geotechnical engineering. It influences design, stability, drainage, safety, and even sustainability. Whether you're building a skyscraper or laying a simple road, never underestimate the power of water beneath the surface and the soil's ability to handle it. This is Blueprint to Reality, where we uncover the forces shaping our world from the ground up. If you're fascinated by what lies beneath your feet, subscribe and join us for more structural secrets and engineering insights.